Hello, math students, and welcome back to Module 2. It is called Arithmetic Operations, including Division of Fractions. And this is Lesson 5, and it is called The Relationship Between Visual Fraction Models and Equations. The relationship between visual fraction models and equations. Our goal for today is, we will use models to prove that equations are true. The question that I want you to think about is, how are division and multiplication related? So there are some things to know that may be a review for some of you, but they could be brand new for others, so I would like to just go over them again. And one of the things that I would like to focus on is remembering that division is the opposite operation of multiplication. And so a lot of times mathematicians categorize adding and subtracting go together, multiplying and dividing go together. And the reason why they go together is that if you add something, to unadd it, you subtract it. And if you multiply something, to unmultiply it, you divide it. And so basically, division is the opposite operation of multiplication, and subtraction is the opposite operation of addition. So some of you are thinking, where is she going with this? Well, the reason why it's nice to remember that division is the opposite operation of multiplication is because if you see something that would be easier to multiply than to divide, then you're just going to remember that you need to do the opposite of that process. So for example, dividing a number by dividing a number is the same as multiplying by the reciprocal of the number. And so I don't know if you guys are familiar with the term reciprocal, but reciprocal is when you have a numerical value, if you invert that or take the reciprocal of it, then what you're doing is you're changing the value of it, because you are going to make it so that when you multiply it, it will always have a product of 1. And so something that we have proven actually in class is that when you're asked to divide by 2, dividing by 2 is exactly the same as multiplying by 1/2. And the way that we know this, I'm going to show you an example. If there's a problem that says 4 divided by 2, we could say that the product or the quotient of 4 divided by 2 is exactly the same as doing 4 times 1/2. And a lot of you are kind of skeptical going, yeah, I kind of remember this. Everyone in the world, I think, in our 6th grade class knows that 4 divided by 2 is 2. Okay, well, let's look at this. If you are doing 4 times 1/2, one thing that I hope your brain has been taught is that whenever you multiply fractions, they both have to be fractions. So in order to take 4 and turn it into a fraction, you have to put it with a denominator of 1, because 4 divided by 1 is still 4. So you haven't changed the value of this number at all by dividing by 1. So 4 divided by 1 times 1 divided by 2, well, let's look at what the outcome would be. Now that they're both fractions, when we multiply, we just multiply fractions straight across. So 4 times 1 is 4. 1 times 2 is 2. So we get 4/2. Well, 4/2, yes, that is a fraction, but it also can be a division problem. And it says 4 divided by 2, and we know that 4 divided by 2 is 2. So we just proved that you come up with the exact same answer, even though the operations are different. So this is dividing again, and this is multiplying. So what we have to remember, the rule being, is dividing by a number is the same as multiplying by the reciprocal of the number. So dividing by 2 is exactly the same as multiplying by 1/2. Dividing by 3 is exactly the same as multiplying by 1/3. Dividing by 4 is exactly the same as multiplying by 1/4. Dividing by 5 is exactly the same as multiplying by 1/5. And then, for some, just to mix it up and see if we can confuse you, if you're dividing by 1/2, so it's already in a fraction, think about this. Yes, I'm trying to trick you right now, but I want to see if you've been paying attention. To undo dividing by 1/2, what you're going to do is you're going to multiply by 2, because remember, this is the reciprocal. Because it's still a fraction, 1/2, so the reciprocal of 1/2 is taking the numerator to become the denominator, and the denominator become the numerator, and so multiplying by 2. So if dividing by 1/2 is the same as multiplying by 2, what is dividing by 1/3? It's the same as, everybody, multiplying by 3. Good job. If you're dividing by 1/4, it's the same as multiplying by 4. So you're starting to see the pattern, I hope. Okay, dividing by 1/5 is exactly the same as multiplying by 5. Now, boys and girls, there's a reason why I'm trying to teach you this, because it's called number sense. The more you know about just logical number knowledge, the easier mathematical operations become. So if you can remember this little thing, dividing by 2 is the same as multiplying by 1/2. Dividing by 3 is the same as multiplying by 1/3. Dividing by 4 is the same as multiplying by 1/4. Dividing by 5 is the same as multiplying by 1/5. Dividing by the half is the same as multiplying by 2. Dividing by 1/3 is the same as multiplying by 3. Dividing by 1/4 is the same as multiplying by 4. Dividing by 1/5 is the same as multiplying by 5. So hopefully this little table can help you remember this so that you can keep studying it and keep practicing it. Okay, so something that we need to do to see if this really works is we need to prove it, because again, I like all of my students to go, yeah, right, Mrs. Nelson, prove it. Okay, and I want you to be able to prove it within your own thinking as well. So we're going to try it, because this first problem that I'm having you try doesn't look like the fractions that we just did. Okay, and so what I need you to do is I need you to apply the rules that we've been learning about dividing fractions by fractions. So we have 3/4 right here, and we have 2/5 right here. So the first thing that we have decided that is the first most important job is to find the greatest common factor, right? And so we do that by finding the least common multiple for both numbers. And so I'm specifically talking about 4 and 5 because we're working with the denominators right now. So the two numbers I'm looking at are 4 and 5. And remember, multiples are what numbers they go into, okay? So if you multiply 4 by a number, the multiple is the result. So 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, and I'm going to stop there, okay? Do the same thing for 5. 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, and boys and girls, the lowest common multiple, I just realized I wrote that incorrectly. It should be LCM. I apologize. I was writing and talking, and that's got really confusing. Sorry, this is the M. LCM, lowest common multiple, least common multiple, has to be 20. So I just found the common denominator, which is the least common multiple, and it's going to be 20. So that wasn't so bad. Okay. So then I asked myself the key questions. How did I get from 4 to 20? I multiplied by 5. What you do to one side, you have to do to the other. So this is 15/20. How did I get from 5 to 4? I multiplied by 4. What you do to one side, you have to do to the other. So this would be 8. And now my division problem is very simple because I have common denominators. I can divide straight across. So 20 divided by 20 is 1. 15 divided by 8 is 15/8. Okay? And so what we need to do is we need to see if we can figure out if this is true by applying dividing by a number is the same as multiplying by the reciprocal, okay, because that's what we've been learning. So let's try it. It says that dividing by a number is the same as multiplying by the reciprocal. Well, remember, this was your fraction division. 3/4 divided by 2/5. That's the problem. So according to that rule up above, that dividing by a number is the same as multiplying by the reciprocal. So my operation changes to multiply. And the reciprocal, if we remember, the numerator and the denominator just switch places, so it becomes 5/2. And then we have 3/4 times 1/2. And if you take 3/4 times 1/2, because it's multiplying, you go straight across. So 3 times 5 is 15. ha ha, 4 times 2 is 8. Now I want you to look. Did you just prove that that rule is true? You absolutely did, because this was the division problem. Same problem right here, okay? We found a common denominator, and we figured out what the answer would be, and now to check it, to make sure we did it right, we can apply this rule of dividing by the number is the same as multiplying by its reciprocal. Notice I said that you only use this to check your answers and to see that you did it correctly, because the standard, as you have read multiple times, does not say I can multiply two fractions together. That is not what the standard says. The standard says I can divide fractions by fractions. I can divide fractions by fractions in word problems. So we're really still focusing on division, but now we're giving you an additional tool to use to help check your answer to make sure that it is correct. Okay? The other thing that I would like to remind you about division of fractions is another thing that will make you showing your level of mastery a 4 rather than a 3 is doing a model. Okay, and I want to try the noun adjective model because I introduced it to you before, noun adjective model, and I want to try it because I don't want to draw 20 boxes, and we talked about that in class earlier on. Drawing boxes gets annoying, and so if we can come up with a different model that is easier to use that doesn't require you drawing boxes, then let's use it. So this problem right here says 15/20, which is the same as 3/4. So 15/20, and with the noun 20ths, with the noun adjective model, the noun is 20ths and 15 is the adjective because 15 describes the noun. So I have 15/20 divided by, you've got to get used to that fraction bar being your division word. So 15/20 divided by 8/20. So my adjective is 8, my noun is 20ths, and now it's a simple division problem. 20ths divided by 20ths is 1. 1 times 15 equals 15. 1 times 8 equals 8. And once again, using a model, we did come up with the same answer as the other 2 times. Okay? And so that's really, really helpful to be able to organize your thoughts and remember it in that manner. All right, so now I'm flipping the page because it is your job to do these problems. And I'm zooming out, I'm sorry, so that you can see all of them. I have 1, 2, 3 additional problems for you to practice. I'm going to read them out loud to you so that you can see them and get them written down. And that is what I want you to practice without me. So the first one to try is 3/5 divided by 1/4. Okay, let me read it again because it's kind of small. I'm sorry, I keep zooming in and out, and that's probably bugging you. So I'll read it again. 3/5 divided by 1/4. You're going to do that one. The next one is 7/8 divided by 3/5. Okay, and the last one is 1/2 divided by 7/9. Now, some of you may be wondering, well, what in the world does she want us to do? Here's what I want you to do. First, I want you to divide the fractions or the fraction by the fraction. That's the first thing that I want you to do. Okay? Finding an LCM, finding a common denominator, that's the first thing I want you to do. The second thing that I want you to do is I want you to check your answer. Check your answer by multiplying by the reciprocal. That's just to check your answer, okay? And then the third thing that I want you to do is I want you to choose a model to prove, okay? Choose a model to prove it, okay? That's what I want you to do, and I want you to do that for each problem on this sheet. So hopefully that's going to be pretty easy because I showed you how to do it earlier. Let's go back in our closing and review our goal for today. Today we will use models to prove that equations are true. We are doing that with several different kinds of models. The question of the lesson was, how are division and multiplication related? And you need to answer that question as well. Okay? So have fun with these last 3 problems doing this way. Divide fraction by fraction. Check your answer with multiplying by the reciprocal, and then choose a model to prove it. You can do tapes, you can do the number line, you can do noun adjective, whatever model you want to use. I need you to see a model so that I know that you understand. All right, kiddos, that's all I have for you in this lesson. I'll see you soon. Bye!